Carboxylic acids. You need to be able to draw and name the first 4 or 5 carboxylic acids. So what's special about the carboxylic acids, what makes them different to the alcohols, is that alcohols contain an OH also, but carboxylic acids must also contain this C double bond O on the carbon that has the OH. So that's the important thing. This will be called the functional group. So the bit that determines the chemical reactivity of the compound is the functional group. So you've now learned 4 functional groups. I keep emphasizing these things. So alkanes was CC, alkenes was C double bond C, alcohols was COH, and carboxylic acids is COOH. There's probably only about 1 more functional group that you need to know if you're at Excel, and 2 if you're AQA. So back to this. The ending of the carboxylic acids is oic. So this one was, the alkanes was ane, this is ene, this was ol, this is oic acid. So monkeys eat peanut butter pancakes. M for methanoic acid. You have a C double bond O, OH, and an H. Now the angles at which you point them do not matter. You could draw it like this. Okay, you could point this down, you can put it on the side, it really doesn't matter. Okay, it'll be very weird, very unusual, but you could do this. Okay, all of it is acceptable. I just did all of them like this. So the second one would be 1 carbon longer, it'll be ethanoic acid, and it would look like this. And then the third one would have like an extra group on the end. The important thing is that this part is always on the end. So if you stick by putting it on the right, you will not go wrong. I mean, you could put it on the left side, but just normally it's on the right. It's just easier for you. Now, these are called structural formulae. So HCOOH. You might say, why is it OO? Well, that's the convention. This is not a molecular formula, remember. A molecular formula will total all the atoms alphabetically. So it will be CH2O. But you see, that's not very useful. If I write C2H4O2. Okay, that would be the molecular version. This is the structural version in sections. So for example, this one is CH3, CH2, COOH. I like to call it COOH, the COOH functional group. COOH. Okay, so be able to name and draw the first 5, I would say. On this sheet, I've done the first 4. But it's pretty obvious that the 5th one will just have an extra carbon there. So the 4th one is butanoic acid, and the 5th one is pentanoic acid. You also need to know that when ethanoic acid is dissolved in water, so aqueous, it is called vinegar. That is something you need to know as a fact. Next, you'll need to know the reactions of the carboxylic acids with metals and metal carbonates. And I'm also going to do with alkalis, just in case. It can be an applied knowledge question. So let's look at the first reaction. Metals reactions, carboxylic acid with metals. Now, the reason I've put redox is to emphasize that this is not a neutralization. A neutralization reaction is between an acid and an alkali, or acid and a base. This is not a base. This is a base if it's a metal carbonate. So this is actually called redox. When an acid and a metal react, from when you were doing salts, it makes salt plus hydrogen. Just the salt is a little bit harder here. So, for example, sodium plus hydrochloric acid would make sodium chloride plus hydrogen. Here, we have just a slightly more complicated looking salt. What you do is you swap these two. The metal essentially displaces the less reactive hydrogen. And this is what you get. So the metal does have to be reactive for this to work. It has to be above hydrogen. So when these react, these swap, so it becomes COONA. The H comes off, but because H likes to be diatomic, it's H2. The easiest way to balance it is to put a half here. Otherwise, we have to double everything. The observations will be fizzing because of the gas, or effervescence. The metal will disappear because it forms a soluble salt. So this will be solid, This will be AQ, gas, AQ. And the reaction is exothermic, so it'll produce heat. Now, the next one I've done on purpose is with a group 2 metal to show you this different, more complicated looking thing. It's unlikely this will come up, but it could. So what you need to know is that the COO has a -1 charge. It doesn't matter what's before it. It can have 1 carbon before it. It can have 2 carbons before it and look like this. When you remove the H, it'll always have a charge of -1. So when it comes into contact with the magnesium, which is 2+, if you remember your ion crossover method from back when you did ionic bonding, this -1 will cross to a 1 here, and the 2 will cross to a 2 here. So to balance it, make it neutral compound, you need to have 2 of these -1s to balance this 1, 2+. So that's why it becomes CH3COO twice Mg plus H2. That's just the way it looks. If it was aluminium, it would be like this. That's even more unlikely, but it will be this. You don't need to know the name of the salt. You just need to know the equations. Most commonly, you'll just have a group 1 metal, so you just swap. For example, if you had K here, potassium, then you just put a K here. Okay, so those are redox reactions. You might say, why? Well, the metal is oxidized. It loses an electron, okay? And the hydrogen ion is actually reduced. It gains an electron. But this is quite a high-level thing, and I don't think that's going to be something they're going to examine with carboxylic acids. You can check out the redox topic of the metals instead. Now, the second reaction we're going to have a look at is the metal carbonates. So please ignore the bit that says esters. So if we in fact put something in the way here, just to block it, I'll just put the syllabus. So ignore this esters bit. What happens when a carboxylic acid reacts with a metal carbonate? Well, acid plus metal carbonate makes salt plus water plus CO2. That was way back in year 9 or year 10. So the only thing you have to remember is the salt looks a bit different. Instead of the H, you're going to again put the metal, the Na, and then you're just going to write H2O and CO2. Okay? For balancing purposes, is the reason I've put a 2 here is because there's 2 NAs here. So the only way to get 2 NAs is to put a big 2 here. Then you would need a 2 here. The observations are effervescence because of the CO2 gas. The solid base will disappear again because it forms a soluble salt. And the reaction generates heat. So it is exothermic. We're going to look at the same thing here as well, just to show you a different perspective. Here the formulae are, the first 4, so they're drawn for you nicely here. We're just recapping now, and then we'll do the final reaction with the metal hydroxide as well. So the first stage is that you know how to draw them with all the different types of formulae, displayed molecular structure. You could work out a general formula too, if you like. So if we base this off of these, it would be, for example, this would actually be C2H5COOH. This would be C3H7COOH. This will be CH3COH, just like it is. So if we use this format, we can see that this number is doubled and added 1. So 3 times 2 is 6 plus 1 is 7. 1 times 2 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. So basically it's CnH2n plus 1 with COOH tagged on at the end. That's one version of it. The second version you could generate from this, where you can see these are double, just like in an alkene. So it'd be CnH2n, then you just put O2 at the end. So that might be easier for you to remember. On your syllabus, it doesn't say you actually have to know it, but I think it's just a useful thing. Okay, so you have to know reactions of metal and metal carbonates, which we've done already. This is just a recap, so you should be able to understand these 2 reactions. Okay, ignore the top one. So metal plus acid makes salt plus hydrogen. Now they've put the names in here. You don't need to know the names, so you can ignore that. But if you look into the chemistry next year and so on, and you're interested in chemistry, then you can learn the name is O8. It's not a big deal. So magnesium ethanoate. They've actually used my type of example with the 2. So that's interesting. Then here they use calcium carbonate. So if we look at this one, because that's group 2, it's Ca2 plus, it also needs a 2 here. And because this whole thing is repeated twice, they had to put a 2 here. Then it made water in CO2. Now the extra one I wanted to teach you was this one. What happens if you do an alkali plus an acid? You get salt plus water. So we've done this one was redox. This was neutralization. This is also neutralization. So sodium hydroxide plus this. Once again, the salt is made by removing the H and putting whatever metal is there. In this case, Na. Because Na is +1 and this is -1, we do not need any brackets for this. We just write the same thing, OO and then Na. Now, because this H came off and because the OH came off, they make H2O, and there's your water. So the reactions that produce water are neutralizations when acids and bases react. This one made hydrogen, not water, and there was no base. So it was called redox. Now, for the carboxylic acids section, this is briefly mentioned here. Carboxylic acids are weak acids. Now, if you do AQA, there'll be an extra lesson on carboxylic acids as what weak acids actually are, because you don't need to know it for Edexcel. So that'll be a separate short lesson. Remember, everyone, vinegar is an aqueous solution containing ethanoic acid. So when ethanoic acid is dissolved in water, it is called vinegar. Okay, that brings an end to the carboxylic acid lesson. So if you're AQA, tune in for what a weak acid is. If you're not AQA, then tune in for the esters. That will be the next lesson. So see you then.